Hello friends, I am Professor Pranav Singh Patil and you are studying weed management. In last classes we discussed about herbicides, classification of herbicides, adjuvants and objectives of adjuvants, different types of adjuvants and formulation of different herbicides. So, herbicides are available in the market in different formulations. So, that we discussed. Now, we are going to discuss about another concept of herbicides, that is herbicide selectivity. Introduction to herbicide selectivity. There are so many herbicides available in the market, and we have also seen one classification of herbicide based on selectivity, as herbicides can be classified into selective herbicides and non-selective herbicides. So, what is this selectivity? Once again we will discuss, and we will also discuss different types of selectivity and what are the factors that affect the selectivity and so on. Okay, so let us begin with herbicide selectivity. So, according to selectivity, there are two types of herbicides in the market that we already studied in classification of herbicide, that is selective herbicide and non-selective herbicide. What is a selective herbicide? Suppose you are spraying a herbicide in the crop field and there are so many weeds. After application you saw that after few days some weeds died and some weeds survived. It means that the herbicide is selective to some weeds, means it is showing some selectivity, it is not killing all the plants. Okay. So, it may be, again we can say, if you apply herbicides in a standing crop, then the target plants, that is weeds, may die and the crop will survive. So, again the herbicide is showing a selectivity here. So, it means that when you apply in mixed plant population, some weeds will die and some we can say some plants will die and some plants will survive, that is selective herbicide. And opposite to this is the non-selective herbicide. When you apply on the mixed plant population in the crop field, with disregard to type of the plant, all the plants will die. So, all the plants which come in contact with this herbicide will die, and that type of herbicide is called as a non-selective herbicide. It cannot select which one to kill and which one to leave. So, it kills all, that is called as a non-selective herbicide. Most of the available herbicide in the market, they are selective herbicide, because they can be used in the standing crop as well as a pre-emergence application after sowing of crop. However, there are popular non-selective herbicide also, like glyphosate, Roundup, it popular by the trade name Roundup, Glycel. So, glyphosate is a non-selective herbicide, paraquat, gramaxone is a non-selective herbicide, whereas most of the herbicide like atrazine, simazine, metribuzin, so they are the selective herbicides. Then the concept of selectivity, it is in terminology we can say selectivity is a phenomena of a chemical to kill the target weed plant species in mixed plant population. Okay. It is the phenomena of the chemical to kill the target plant species in mixed plant population without affecting other plants. So, I told you earlier that it kills some plants without affecting others. That phenomena is called as selectivity phenomena. So, selectivity of herbicide can be of two types. One is true selectivity and another is placement selectivity. True selectivity means herbicide itself is having the phenomena of selectivity. True selectivity means it is the selectivity because of the nature of the chemical, whereas placement selectivity, it is because of the method of application, where you are spraying the herbicide. Okay. So, method of application, process of application, the place of application decides the placement selectivity, whereas the by nature a herbicide chemical also shows selectivity, that is called as the true selectivity. So, most of the time when we refer to selectivity, actually we refer to true selectivity, but sometimes due to placement also we can achieve selectivity, that is called as a placement selectivity. So, true selectivity, when a weed plants die from mixed plant population of crop and weed, due to differential action of herbicide within the plant body. Why this happens? When you apply herbicide, some plants die, some plants survive. Why this happens? This happens because there is a differential action of herbicide within the plant body. There are two plants in the field. One plant is dying after application of herbicide, another plant is surviving. It means that the plant which is surviving has some mechanism to adapt against that herbicide. It may be not absorbing the herbicide, it may not be translocating the herbicide, it may have a deactivation enzyme inside the body. So, there is a differential action of herbicide within the plant body of different plants that is responsible for true selectivity. Okay. So, this is what happens inside the plant body. So, this is a physiological example. Now, actual example, a real time example, propylene is a popular herbicide used in rice crop. So, propylene shows a true selectivity for rice and barnyard grass. Barnyard grass is a weed in rice crop. Barnyard grass, Echinoclea species, a mimicry weed of rice, looks exactly same as rice, but when you apply propylene as a post-emergence herbicide, it does not affect the rice crop, but it kills the barnyard grass. It is a mimicry weed, laborers cannot identify it. So, that is why that weed survives, but chemical has the ability to identify what is rice and what is barnyard grass. Why the chemical identifies? Because of the differential physiological action inside the plant body. So, what is that differential physiological action? That is presence of a enzyme in rice. Which enzyme is present in rice? Aryl acyl amidase. So, rice contains aryl acyl amidase which deactivates propylene, whereas the barnyard grass does not have this enzyme, and that is why the propylene kills barnyard grass and rice survives. Then the second is the placement selectivity. Application, we can say plant species respond differently to same herbicide due to different placement methods. Plants respond differently to same herbicide due to different placement. Suppose a herbicide is a foliage applied herbicide and you are applying it as a soil application, then it may not kill, it may not produce the desirable results. So, plant species respond differently to same herbicide due to different placements, and that is called as placement selectivity. So, it may happen in case of soil applied herbicides, okay, placement method. One or two examples can be like soil applied herbicides. When you apply as pre-emergence or pre-plant, they should form a thick layer on the soil. So, there should be a presence of moisture and herbicide should go down at least 5 centimeter, thick layer should form, and then we can expect that the whatever the surface weed seeds are there, they will not germinate, or even if they germinate, they will immediately die. So, this application of herbicide on the soil surface kills the surface weeds. However, the weeds which are present below the 5 centimeter depth, or we can say the seeds, crop seeds which we are sowing below 5 centimeter depth, nothing will happen to the crop seeds, and the weed seeds will come in contact with the herbicide. So, more weed seeds will come in contact with herbicide, whereas the crop seeds which are sown at 5 centimeter or more depth, they are not coming in contact. So, any phytotoxicity symptoms, there are less chances to the crops, and we can say the weeds will come in contact. So, that is a selectivity by applying herbicide on the soil surface. Another method is application of herbicide in between two rows of crops, that is called a directed spraying. Suppose this is a crop row, it is another crop row, and you are applying herbicide in between these two rows of crops by attaching a plastic hood. Okay. So, directed spraying is, it means that you are giving a direction to your spray and the spraying happening only in between two rows of crops. You are taking care that the spray is not going on the crop rows. So, again you are achieving the selectivity you are achieving the selectivity by following a particular method of application. One is you are applying on the soil surface to kill the surface weeds and sowing the crop seeds at higher depth. Second is you are applying in the standing crop herbicide and you are giving direction to your spray in such way that the herbicide should not fall on the crop row. That is a direct. It means you are achieving the selectivity. You are protecting your crop and you are killing the weeds. That is also a kind of selectivity called as a placement selectivity. Now, what are the factors affecting selectivity? The factors are: number one, age of the plant, soil moisture availability, morphological differences and physiological factors, as well as other factors. Age of the plants, young plant versus old plant. What do you think, young plant versus old plant? Which of the plants will have more toxicity, or we can say absorption, and what will happen to herbicide selectivity? See, if there are young plants and old plants in the crop field, the herbicide will kill young plants and old plants may survive. So, herbicide is showing a selectivity towards the young plants. Why? Because young plants have succulent and they have faster metabolic activities, they have faster absorption and translocation, and that is young plants are more likely to be killed. Then moist soil versus dry soil. I told you earlier, especially the soil applied herbicides, they need some moisture so that the herbicide should go deep into the soil, at least 5 centimeter depth, and form a thick layer. As well as if the moisture is available, the plant metabolic activities are happening at a faster rate. So, in moist soil, the better weed control can be achieved as compared to dry soil. Then morphological differences, broadleaf versus grasses. Some weeds have broadleaf, some weeds have grasses. Broadleaves are more susceptible than grasses. Grasses are more hardy, resistance to herbicide application, and the reason is the broadleaf weeds, they have a larger surface, we can say broadleaf weeds, more time the herbicide gets to absorb as compared to grasses. The herbicide immediately falls on the soil after application of the herbicide on grasses. So, it is difficult to control the grasses because of less we can say surface area where the herbicide can stand, and more in case of broadleaf. Smooth leaf versus rough leaf. Now, in case of broadleaf or in case of grasses, if the plant is having a rough leaf, then the herbicide will stand on the leaf. If the plant is having a smooth leaf, the herbicide immediately falls down on the soil. So, rough leaf surface is useful to kill the plants, whereas the smooth leaf surface is not so good. Stem with thin bark and stem with thick bark. If the plant or weed is having a thin bark, it will be easily killed, whereas the thick bark weeds like Lantana camera or Prosopis julifera, they are difficult to control because of the cuticle is not allowing the herbicide to move inside the plant body. Stem with thick here and stem without here. Stem with thick here and stem without hairs. So, when there are so many hairs on the plant body, if too many hairs are there, again the herbicide will not come in contact with the stem and may fall down immediately. Whereas, without stem, without hairs, the herbicide is coming in contact with the leaves and stem, so more chance of absorption is there. Then physiological factors like differential rate of absorption, differential rate of translocation, differential rate of deactivation and differential metabolic processes are there. Differential absorption, the herbicide is having a differential absorption. Just now I gave example of grasses and broadleaves. So, morphological differences, they affect the absorption and differential rate of absorption. Grasses, they have less absorption because of these narrower leaves, whereas broadleaf has more absorption because of the spreading type of leaves. And the absorption can also be controlled by use of some adsorbents like activated charcoal. Now, this is useful in case of preventing the toxicity of herbicides. So, activated charcoal, if you use against 2,4-D, imagine nitralin, okay, you give a seed treatment of this activated charcoal, or you apply this in the crop row, and then you apply this herbicide in the field. Then what will happen is this activated charcoal will herbicide near the crop row and will keep the crop safe. So, crop is not absorbing the herbicide because of presence of activated charcoal, and that is why there is a less absorption in the crop, more absorption occurs in the weeds, and weeds will get killed. So, differential absorption because of use of a outside chemical like activated charcoal. Use of antidotes can also be used to prevent the phytotoxicity and increase the selectivity towards the weeds. Antidotes are the chemicals which antagonize the phytotoxicity of specific herbicide to specific crop. So, they have a reverse reaction. So, the antidotes, they neutralize the herbicide, okay, they neutralize, they we can say they stop the action of herbicide. So, antidotes like YAMA R25788 against EPTC herbicide, okay, and against the butylate herbicide, CGA 43089 against metaphor in sorghum. So, if you by chance if you use metaphor in sorghum, which is a toxic herbicide, and you are seeing some symptoms, to keep your crop safe, you can apply CGA 43089, which will nullify the effect. Differential translocation, even after same level of absorption, 2,4-D and 2,4,5-T have different speed of translocation. So, absorption is same, but translocation speed is different. Different formulations of same herbicide also has different speed of translocation. So, we have studied formulations like amine salt of 2,4-D, emulsifiable concentrate of 2,4-D. So, emulsifiable concentrate is more fastly absorbed and translocated as compared to amine salts. So, that will also show the differential selectivity. Then differential deactivation of herbicide. A tolerant plant species deactivates the herbicide molecule rapidly. Just like we gave example of the propylene herbicide in rice crop. So, rice deactivates propylene. So, differential ability of plant to deactivate herbicide, okay, that will decide the selectivity. Differential metabolic processes, whether this metabolic processes are happening at faster speed or the slow speed, that will also decide the selectivity. In young plants, the metabolic processes are happening at very fast speed. Then other factors like rate of application. If you apply at optimum dose, then you can expect desirable results, but atrazine act as a soil stimulant when used at high dose. So, rate of application also affect the selectivity. Actually, herbicide atrazine is a selective herbicide, and you brought in from the market and now you are applying in the maize crop. But if you apply with the extra dose, then it will cause soil sterility. It will not allow the maize or the sorghum seeds to germinate because of excess dose of application. It causes the sterility. So, herbicide no longer is selective because of excess dose of application. The growth stage of plants. So, wheat, for example, in case of wheat crop, wheat is susceptible to 2,4-D at seedling stage. Actually, wheat crop 2,4-D herbicide is recommended in wheat crop, that you can apply the 2,4-D herbicide to kill the broadleaf weeds in wheat crop as a post emergence application. But when to apply? Apply the 2,4-D herbicide at seedling stage, at early stage, it also has phytotoxicity symptoms of wheat crop. So, 2,4-D is a stage specific herbicide. It has to be applied when the wheat crop is at tillering stage or maximum tillering stage. So, it means that wheat crop is showing selectivity at some stage and it is showing a non-selectivity at some stage. So, this is about the selectivity of herbicide and the factors affecting selectivity of herbicide. I hope that you have understood what is the concept of selectivity and types of selectivity, and how we can achieve the selectivity by also by following proper methods of application. For today, we will stop here. Thank you.